I just wrote one line. You did it. Okay. Corollaries are just things that are attachments to the original theorem, but I wanted to show you how to prove this one because what makes real analysis so different, I think, is that there's no stock proofs. There's a trick for everything. And if you've not seen the trick, it's just, I remember the trick. So I have now a lot of no's because I have theorem 2.2, I have the definition, I have the triangle inequality. But the most powerful one that you're going to get in this class is actually the triangle inequality. It's every time I use it, I'll go into falsetto so that I just remind you that this is like, here we go again, triangle inequality. It's the most important thing that you will use, even though it seems so innocent and obvious. So here is the triangle inequality. I put it with x's and y's because I intend to substitute. So that'll give the reader an easier time substituting if they say I'm substituting this for x and substituting this for y. So I'm going to prove my theorem. I'm going to let x equal a and y equal minus b, which I'm allowed to do because the triangle inequality is true for all real values. Good? Okay, so I usually copy the previous one so that I can use that same thing. So if we substitute that in, that's what we get. And you can already see it's all she wrote. Document everything. Don't make things up. Fred from your high school teacher doesn't count as documentation. It's got to be something that's in the book. And on page 32, they say absolute value of minus b is actually b. So I get exactly that corollary as desired. So the trick here is just substituting something in. I remember getting a lot of these kind of problems and just sitting at my desk trying to figure out the inequality and making it work. And sometimes the inequality feels like it's going the opposite way than I need it to go. I've done a lot of these kind of proofs as an undergrad. Here's another one. Do I need to go back? Eh. Here's another one, another corollary. There were two to the triangle inequality. This is one where if you don't know the trick, it is going to feel like, and of course my real analysis teacher didn't give me the trick. My undergrad real analysis, well, he didn't make us do homework. Let's just say I didn't learn very much. No one's going to make you do this homework, no one's going to do it. So that cadet candidate said, how do I learn how to write proofs? I kind of have to write proofs. But if someone's not making you do it, I don't really know how you're going to do it. That's like making, doing sprint, drag, and carry just by yourself. So if someone doesn't make you do it, wait a minute. All right, here's the proof. What you do is you write A as A plus B minus B. You're just adding a zero. So it's a trick that we use in real analysis. You're going to see this again.
My calculus teacher, who was Polish, talked about tricks like this. Like he called this the Polish zero, and then for the fractions he called it the Polish one, because like the Poles have a very overcomplicated way of doing things.
Oh wait. I remember actually Cadet Chris Perry, who's now Lieutenant Colonel Chris Perry. I'd tell him to add a zero. I meant him to do this, and he would stare at me for a while and go, A plus 0, and then look back at me again like, no, add a 0, because I'd seen this trick so many times. I knew what I was talking about, but he thought I was insane. I rearranged things from the minus b to come first, and I really should put Kennedy by the commutative law of addition. I'm allowed to do that. See, she's actually the only one that put the distributive law up there. Oh, you saw it? Okay. Somebody else put it too. Algebra classroom. Really should put that detail up, like how did I get from here to here, commutative law of addition. And then by the triangle inequality with x equals a minus b and y equals b, I just apply that sucker to what I have, and I get that thing. And then I subtract absolute value of b from both sides, and I have what I desire. Pretty slick. It seems wrong, right? Just abusively wrong. So at Montclair, we didn't have an intro to proofs class. I don't think there's really a way, like people want to make it gently, you gently go into this. Like, no, you just kind of have to cry for about a month and then you get used to it, regardless of what class you're in. But they would sit in there, and we had, I think, the vast majority was math education students, so they were going to teach high school. So in their heads are thinking, why am I ever going to need this to teach high school? So I have an angry mob sitting in front of me. And then I remember showing them things like this.
It's a hell of an attitude for somebody who's going to be a teacher. Oh, I can do that.
Well, if you want to go be a teacher, you're probably thinking very direct of what you need to do, right? So all of a sudden you're in your comfort classes, and then you're plugged into a class like this with no introduction to proofs.
I just can't imagine being a good teacher and not also have just
A desire to learn?
Curiosity, like love learning. It just seems contradictory.
I think that's the human nature. When I came here, I didn't know R. And I was looking around, who has SPSS? And the math department said, go to BSNL.